My students, my students don't like it when I give multiple choice with like 8 potential
Oh
answers.
yeah. A, B, A, B, C, A, C.
That's right.
I see that 3 to 5 is the most common answer.
I know. Well, maybe you shouldn't see what other people put, but don't have what other people do bias your voting.
Are you gonna show us the result, Dr. Wester?
The result or the answer, the right answer.
Okay.
We'll get there. Well, yeah, so I'm going to give you my perspective on these. So I have three questions like that. So hopefully, it's always hard to do it on Zoom, the presentation and Slido, but so you can see the results on yours, so right? As people are voting, can you see the results?
Yes, we
We
can see the
Yes.
result.
You can see them.
Yeah.
Okay.
Yeah.
Yeah, we'll get more people voting here after we start.
Sure. We will take 1 more minute, and then
Okay.
we'll start. I'll introduce you in the beginning, and then you can go ahead. We can have questions in between or at the end as you like.
Yeah, we'll pause in between
Sure.
with each of three fun Slido questions. So if you came in late, I'll repost it again. I think sometimes, and Saeed, maybe as after we get started, if you can repost that link.
Sure.
I know you're letting in everybody, but yeah, because we
Oh,
don't
sure.
get to that. We don't touch that question for about 10 minutes or so. So I thought people could start voting.
Sure.
It's fun seeing so many people I know.
We have around 150 people registered for
Oh
it. So
wow.
yeah,
You're going to be clicking admit, admit, admit a lot.
yeah.
There's no
My
easy way to do it, is there? At our university, you can't get around it.
my student Biraj is helping me with that.
Okay.
I made him a co-host, but you can also admit a lot of people together, like admit all together. That helps.
Yep. Whenever you're ready, we can start. People
Sure.
can keep joining.
Yeah, sure. Let's get started, everyone. Good afternoon. And this session is offered by AESP Community of Practice, Grantastic.
I was on my way out, started by my surgery this morning at Rose City Methodist.
Let's see who is talking.
Is that the one you see behind?
Yeah, please mute yourself there. I think it's Nahid. Please mute yourself, Nahid. Okay, this session is offered by ASP Community of Practice Grantastic, and we are excited to kick off version 1 of this series, where seasoned faculty will share how they make grand decisions in real life, what to pursue, how to ignore, how to stay productive without losing sanity, or other things they seem fit. Today, we are honored to host Dr. Westerhoff from Arizona State University. He's a Regents Professor, Fulton Chair of Environmental Engineering, and Director of the Global Center of Water Technology. His work spans water treatment, reuse, nanomaterials application in water purification, and micropollutants fate and transport. Dr. Osterhoff has received many honors, including the 2025 Perry L. McCurdy Founders Award, 2020 AP Black Award, 2019 NWRI Clark Prize, multiple ASU Outstanding Doctoral Mentor Award, Arcadis AESP Frontier in Research Award, Paul L. Bush Award, and the most recent one I just found out from his LinkedIn page is the 2027 Simon W. Friess Award from ASCE. Dr. Westerhoff was elected to the National Academy of Engineering in 2023. We are excited to have you here with us, Dr. Westerhoff. This session will be recorded and shared later on. Please take it from here. The floor is yours.
Great. Thanks, Saeed. So I'm going to have 3 Slido questions. So Saeed, maybe in a few minutes after more people join, you could just repost it again. And
Sure.
we'll kind of stop along the way at like 2 or 3 places and kind of ask for your opinion on things and share them. So, I did not come up with the title of this. Saeed volunteered the title and it sounded fun, so I kept it. He said he was inspired by bacteria, so I'll believe him. So thanks. I'm going to kind of talk about, some perceptions or, what motivates me in terms of writing grants. Just a little bit about me and beyond kind of the background there. So I joined Arizona State University in 1995. So I've been here a long time. It's changed a lot. But in addition to being a professor, I've also been a department chair. I founded the School of Sustainable Engineering, the Built Environment. I've been an assistant dean, a vice provost for the university, and a vice dean in engineering. And so, at least for today, my guiding principles: proposal writing is fun when I focus on creating value for someone. And so sometimes it's selfish, creating value for myself. I've written proposals I never thought would get funded, but I learned a lot in writing the proposals. And sometimes I create value for other people. So I'm going to focus a lot on that idea of kind of value creation. But I decided to start by like things that are out there. And I Googled, how to write a grant, and this roadmap came up. And I think it's a little too linear. I think it's a little too simplistic. And I don't suggest it. So if you like it, that's fine. So, I'm going to say they really kind of missed the point here. These were like the logistics of how to do it rather than why are you proposing something? What is this need, this unrecognized need that you're trying to solve that somebody has? Either they know it or they don't know it. But I think the real need of writing a proposal is to create value. So it's not about getting money. It's not about doing something that you think is fun. Maybe that's value to you. But in the end, I think, research grants, if you're successful, creates value for somebody. And you really need to keep that in the forefront. And I think funding always follows the creation of value. So if you create value, money will follow that and not vice versa, I don't think. So I'm going to talk today a little bit about creating value propositions, and that creates funding for your research team to do kind of the things that we enjoy doing. So with that as an outline, I'm going to talk about some different things, some things that maybe Saeed asked me to, or maybe not, but kind of lessons along the way and how I perceive things. If you like, hydraulics, maybe you can view this as, kind of waves and wave energies. And where do you want to be on a wave? Do you want to be starting something? Do you want to be in the middle of it? Or do you like being, following through and getting all the way to the beach and really understanding the details? And I'm going to do this by sharing some statistics, talking about different approaches for different size proposals, and go from there. Is that okay, Saeed? Give me a thumbs up if I didn't share my outline with you. Is that okay?
For sure.
I didn't know what you wanted, so that's what I came up with.
Sure.
So, I'm going to start by saying some advice I give to junior faculty is maybe really think about creating a funding portfolio. And so that creates value for different types of end users. And so you can think of a value a portfolio. Oops, I'm going to stop. It looks like I'll reshare. I have some automatic timings that are no fun in here. You know, think about a portfolio as funding sources, but maybe also the types of things that you're doing. But it should all start with creating value for somebody. And if you kind of create value, I would argue that then you're going to recognize the impact that your research is likely to have. And that'll feed into funding sources if you really understand who it is that you're going to make an impact on. And then that leads to money. And whether you go after small amounts or bigger parts, and how long things are, and the idea that you build partnerships. They might be with your research students or other faculty or companies. And in the end, I think if we fund research to do it, then we create value, and this whole cycle kind of goes around. So I really don't think about one proposal at a time, but really kind of how all these things iterate together. So I'm just going to stop for a minute because it's having, let's see, I'm going to reshare it. I just have too many screens popped open on me here. Give me just a minute. All right, try one more time. So I'm trying to get this Slido thing running in the background, but maybe I'll stop that. Okay, so, I'd say after we kind of go through this little cycle of thinking about creating value and how that leads to funding, and then funding allows us to do what we want, and that creates value for somebody. That, how do we get there? Or my insights is that, practice makes perfect, right? As faculty, we teach students in class to practice things, practice homework, practice exams. We've learned over the years how to do research. We've learned how to write papers, but I don't know, who taught us on how to write proposals. And it's been much more of a throw into the fire and kind of see what happens. And so I'd argue that the art of proposal writing, the more proposals you write, the more practice you get, and hopefully the better you get, or you find a different profession. But there's a real interesting question. I was going to make this a Slido thing, but I only get 3 free Slido questions. But who writes a better proposal? An assistant professor that might have really exciting new ideas, or a full professor who has a lot of practice writing proposals? So think about that when you've been on a panel. Which one of those writes a better proposal? There's no answer. It's just an interesting kind of thought. And that I would say that the full professor with a lot of practice might be able to, convince people of things differently than an assistant professor. So writing proposals is really, trying to convince somebody of something, but what is it that you're trying to convince them of? Hopefully you're trying to convince them that you have a unique and important value proposition to someone. All right, so here's the first Slido question. How many proposals should you write in a year? And so let's see, if you didn't vote yet in Slido, I'm going to stop sharing so I can put it back in here. Take a minute. I'm going to share my slide screen here. Let's see how people are voting. So we have 30 people so far. About half the people say 3 to 5 proposals a year. No one says 1. And we have 10 to 12. No one's over 20. 5 to 7, 3 to 5. So it's interesting. I'll keep that running and people can kind of, watch it there. And I'll give you my perspective, maybe as kind of a former administrator and different things. But I think there's different ways to think about how much practice you need. So I sent this to 300 ASU faculty in engineering when I was in the dean's office. Got a really mix of feedback from people. You shouldn't be telling people what to do. I said, I'm not telling people what to do. I just like giving people data and arguing maybe that practice does make perfect. And not all proposals are equal. And we'll talk a little bit about that in a moment. And there could be a PI role, co-PI, senior investigator. And I'd say that a mix of these may all go in. So I didn't say how many proposals per year should you write as PI, right? That might be different than if you consider any potential role. And you can learn from people if you see how they write proposals. And it's very different than what you get in the end on a panel, because everyone kind of, cooks Thanksgiving turkey differently. And it's really, some people do it weeks in advance, some people do it the morning of, and that whole process, you're going to learn things from them. So I'll give you my analysis, and then I'll tell you how I got it. But I looked at 10 years of data at the Ira Fulton Schools of Engineering. I'll show you some of the data in a minute. And all I can say is that assistant professors who submitted, or part of them, they were part of 8 proposals a year, always got tenure. 8 proposals a year for every year, they always got tenure. Now, others got tenure too. So I'm not saying that this was the only way to get tenure, but I thought it was a really shocking, outcome. So I'm not saying 8 is the answer, but that was an interesting pattern. So, what did I do? And so I used some statistics. So I'm going to go to our second Slido question here in a moment. But what size proposals do you want to get funded as a PI? Okay, so think about that for a moment. I'm going to go to this, open the second Slido question here. So it's the same Slido link. So go in there and start, filling in what size proposal do you want to get funded as PI? Okay, interesting little trend so far. So keep populating that, and I'll go back PowerPoint here and share. So, I'm going to think about some statistics. And so this is the statistics I shared with engineering faculty when they got mad at me. And so I took 10 years of data. So this was 2005 to 2015 across all of engineering, all faculty, any given age group and demographic group and everything else. So this is, electrical engineering, computer science, civil engineering, environmental engineers. So 3 different lines on here. So the first one is the blue line, proposals. So it's the the dollar value of the blue line is proposals submitted by engineering, over this time period. And, so it's billions of dollars, tens of billions of dollars about for this time period. And the largest dollar value was in the $1 to $5 million range. Okay. And, it wasn't the $20 million and above range, right? It's just saying that there's a lot more, the total value is in this $1 to $5 million range. All right, then if you look at on the green line kind of follows the same trend as the blue line, right? The largest, total awarded, about $1 billion, was in the $1 to $5 million range. And then what the interesting pattern is the success rate of different size proposals. So what it says here is under $100,000 proposal, the success rate on the left-hand side is 65%. So we all wish we had 65% success rates of every proposal we ever wrote, but that's true for smaller ones. And if you've been doing this for a while, these are someone asks you to write something, you're usually not competing very much, and it's really, did the money work out, right? Did they move it? And 100 to 250,000 success rate is about 40-45%. And, in the standard NSF range during this time, it was around 22%, right? But then look, the pattern, 500 to a million, it's about 22%. Maybe it's 20% in the 1 million to 5 million. So in engineering, these are things like ARPA-E proposals, a typical RO1 to NIH. But then look, it goes up, 32% success rate in the 5 to 10 million, 25 or 28% success rate, 30%. So really there's no change in the success rate once you're above about $250,000. So as an environmental engineer, I thought I was happy with, 250 to 500,000, but I look at the statistics and they say, hey, for the same probability, if I'm in Vegas, I might as well write something bigger, right? Why should I be spending time writing, something in the $200 to $500,000 range? So again, I don't know if it's not an answer. I'm just saying these are statistics, right? And if you could make a small improvement kind of in this amount, the green line goes up, and from an administrator in the dean's office, that's pretty powerful evidence of where you should help faculty. So when I was in the dean's office then, I really helped faculty who had never submitted a proposal over $1 million to try to move into that range, because the type of proposal you write, especially as an environmental engineer, changes, right? And so to try to think about that. And so here's some real data. This was the last year I felt like safe enough. It was pre-COVID. It's not recent, but this is in engineering. I'll just show these are the actual dollar amounts proposed to different agencies. On the top, it's NSF, NIH, DOE, DOD, and then domestic companies, then USAID, that doesn't exist anymore, but then the Department of Transportation, Navy, Army, et cetera, right? So it drops off pretty quickly in terms of where people proposed. A little bit more complicated graph, but it gets at the same thing. This is the total on the left is, hundreds of millions of proposed kind of running annual average. This is what all the administrators in your universities have, that looking at these dashboards. But the inset there shows the success rate is pretty constant, 20 to 25%, right? And then they predict out into the future so they can see what type of success rate and overhead will be generated, for example. So these are real data. My point here is that this is real data. These are success rates, and small proposals, large proposals, you could keep diving into them, but I showed you that on the previous one. And this data is not atypical at Arizona State. This is free data I saw for NC Chapel Hill in terms of, again, about 70 or 65% federal, and then these other kind of distribution. And so does this make sense, a 20% success rate? So, does it make sense in the context of 8 proposals a year? Well, let's think about it. So if you want to support a research group with 4 or 5 students or postdocs that you pay, how much money do you need? Well, it keeps changing, but maybe $100,000, let's say, per researcher. So you need to have a steady state awards of $500,000 a year. And so, if your success rate is 20 or 22%, you can think about how many, but it actually works out to be pretty close to, if you have a nice portfolio, small, medium, and larger collaborative grants, some high probability, some lower probability. And if you take this and say, about 8 proposals a year, you can support a group of about 5 researchers, right? So 8 at a 20% success rate means you're getting 2 or 3 funded per year, right? And that's kind of how all the math works. And so it's just an interesting pattern that you don't need to follow the success rate as an investigator as much as how many proposals are writing and that you're getting practice over time. So let's stop there for a moment and go back to see what people said. And so this was this is how I used to think about things in terms of, as an environmental engineer, in terms of where did I decide to spend my time writing proposals. Most people said 250 to 750. And, that's a single PI-ish thing, maybe one partner, right? But then you're going to have to write a lot of those every year if you really want to fund a group. So some people, smaller ones, maybe this is what you want to get funded, right? So maybe this is saying people enjoy single PI. Not as many people are ticking these larger ones, which would definitely be multi-PI types of things. So I think that if you want to think about sustaining a research group over time, having a balance across this whole portfolio would be one of my thoughts or recommendations to people. You should always be thinking about getting into this $1 to $3 million kind of range as you build up your career. But in order to do that, you should be part of them early on, so you see the practice that people are making and how different people go about making them. So let's keep going. So I'll break now. I thought I'd dive a little bit into those, but maybe I'll pause there for a moment and see if there's any thoughts or questions or anyone violently disagree with me.
I do have a question. So, how does there's some correlation between the size of the proposal and dollars that go to your research group, right? So, in a $20 million proposal, it doesn't all go to I assume, right? It doesn't all go to your group, right? So,
Right.
can you talk about maybe like the cost benefit analysis of saying like, okay, that $5 million proposal will get me a PhD student and postdoc for 3 years, or what that looks like versus a single
Yeah,
PI and that kind of thing.
exactly. And so I'll get to a little bit when we get down to the center proposals, kind of part
Okay.
of the outline. But kind of think about it. Um, there's tools that you can do, right? So you don't put in the same effort unless you're leading it, say a $20 million proposal, as you do on a single PI. I would argue a single PI one is a lot more work. Maybe not a lot more time, but definitely a lot more work. So, Gary, if I can hold off a little bit, we'll talk about some of the tools that can help you be more successful. But
Yeah, no.
yeah, you should go into these things you know, um, thinking about creating value instead of how many students you get out of things, if that makes any sense. This is going to be my message kind of throughout, that if you create value, the money for your group will follow that. But yeah, go ahead, Fernanda.
Hi, Paul. Thank you for your presentation so far. I did my PhD at the Sustainable Engineering School at ASU, so
Hey, yay.
thank you for that. I have one of the questions that I have is related to this. How would you say that those conclusions that you're drawing from, how would you say they vary according to the resources that each different institution may have? I know you guys have a lot of resources, and other universities across the country may have a different amount. And that relates to my second, it's not a second question, but it's a second variable as well. How does that hold true today in the environment that we are facing right now?
Yeah. So I would say that if you don't submit proposals, you won't get them funded, right? And so, I think that the success rate is largely the same today, this year, as it was in 2019. Um, so you have to be, it may not be in your field exactly. So that was looking across all of engineering. There's always things that go up and down. And so that's why in the first slide and on the outline, I'll go back to the outline and I'll try to answer your questions. That, I have this wave and these waves on here, right? So things go up and down, and you need to be looking for that next wave to surf. And it may not be like jumping over to machine learning if you're not a machine learning person, but you need to be kind of proactively thinking, where do you like operating on things? Is it early technology readiness level? Is it new ideas? Like, where is it on these curves? And you should be rolling the dice a little bit. You should be, surfing the part of the curve you really enjoy, but you should also be thinking of that other wave that's coming and throw something out there. Roll the dice. Maybe you're not the PI of that one, but maybe you bring something to it. So you learn something about a topic, say quantum physics, right? So quantum is a big word. Why aren't more environmental engineering doing quantum, right? But there's a lot of people doing it and thinking about it. And so one way to learn quickly is to write a proposal or be part of a proposal with someone. So, so I think I'll answer part of your other question, your first part, in terms of smallish proposals, right? So when I started at Arizona State University, it was a small school. I taught evening classes. We had no PhD program in environmental engineering. And so I'd say, yeah, I was at the school that you just kind of described. And so, one place to think about this is smaller grants. And so these usually aren't federal agencies, but they might be people, counties. I did a lot of work initially with the U.S. Geological Survey, small grants. But what I learned a little bit is to listen. And so do a little bit what you want, but really don't tell people always what you want, but kind of listen to what they think are pain points, what they really think are needed, and do a lot more listening than you think is important. And I think this is the biggest change from like a PhD or postdoc to where you're telling people what you can do. You're trying to get a job, you tell them what you can do, but to get convince money to someone to give money, I think listening is really important because then you can create kind of a value proposition and really try to understand what their need is before you force upon them kind of your approach. So they want to work with you. They've found you usually on these smaller ones. Again, 60, 70% success rate. So, there's something there, but, industry does this type of smaller research usually for three reasons. And it was really a guy who used to work for Intel that told me about this. So it's not their primary job. So they have, you to do it. So they'll learn from you, but it's not really their critical thing. They kind of miss being in grad school, right? And they just want to like keep in touch. Their competition thinks it might be a good idea, so they don't want to be left behind. This is called defensive research. They're like, let's have the university do that instead. And if it works out, then maybe we'll switch directions. And third is it's beyond their time horizon, right? So whether it's in like a USGS office or the state or, other partners, that if it's outside of like 1 to 3 years, they're thinking about it all the time, but they usually don't, it's not critical for them to do. So I think it's really important that you listen to understand which of those it falls into. And then you can decide if you want to do it, right? But if it, then I think it helps you position how do you create value for them in funding these smaller grants. Because if they fund you once, they're likely to come back many, many times. So there's a water power agency here. Maybe you remember Salt River Project, Fernanda, but they fund projects. They've been funding small projects at Arizona State University for 40 years. In engineering, they fund about 30 projects a year, each one geared at funding one student for 1 year. I probably have had 20 projects from them over 30 years. So they keep coming back because somehow they think I'm providing value to them. Okay. So you can get burned out on doing lots of small grants. Usually one per year maybe is good. They're easy to get, but they take a lot of time to execute. And I still like doing these. I still do projects under $25,000. Usually not too much less than that. I learn a lot. Like a lot of these are with consulting companies or cities, and I learn a lot that then I kind of integrate into larger proposals. I would say that avoid what I call the $3,000 to $5,000 traps. So AEESP probably has some of these. I wish they'd stop giving away $3,000 to $5,000 in competitive research things that sound like some type of seed grant or something. So these are traps. They are wastes of time. It takes you, think about your hourly rate. It takes you more time to write and submit these than the value you'd get out of them. Now, I just say avoid. I don't say don't do them. If you're creating value for yourself or you're doing this to teach somebody how to write a proposal, it's useful. But these are in these smaller grants. I'd say have a purpose, be strategic, be sure that they can leverage other things in your group. maybe existing grants, future grants, visibility, getting into a new area, types of things. So that's my philosophy, Fernanda, for these, how do you get started? You start with small grants. No one will give you $10 million if you've never had $1 million project as PI. No one will give you $1 million unless you've had a $100,000 one. So this is a good place to start. But
Thank you.
maybe I'll pause there. Did that help, Fernanda, or any other questions?
Yes, that helped. Thank you so much.
Right. And so let's see how we're doing back over here on our Slido poll. Let's see. Let me go back here. So we'd asked, what size proposals? There were a lot of people still in that middle range. And so I'm going to open this third poll, and we'll look at it a little bit later. It's kind of a word bubble. But what's one word that describes what you think are the hot topics getting funding, the hot topic for you that are going to get funding today? And I say today, not yesterday, but today. Okay, so keep that in mind, and I'll go back to the presentation here, and we'll cycle back to that a little bit later, but hopefully people can start populating it. So again, the smallest proposals, high success rate, very opportunistic, usually. So in this middle range, these are your standard NSF ones. What I want to do a little bit now is how do I write these proposals? How do I think about approaching a value proposition? And it'll be through this, and they're in relative size of importance. The need is more important than your approach. The benefits are more important than your approach. And your approach and your competition are equally important. And so unless you hit on all of these, you will not have as compelling a value proposition as other people may have. So these are the classic, NSF, what used to be EPA, but even, NIH, DOE, DOD types of things. So these are usually lower technology readiness level. So understanding kind of where you are. So higher technology readiness level that requires pilots or demonstrations are usually more expensive than this range. So like phase 2 SBIRs, for example, are now well over $1 million in almost any agency. So to go higher technology readiness level, usually you're outside this range or at the high end. So I think it's really important that you understand the review process. Sometimes it's peer review, sometimes it's not peer review, sometimes it's a hybrid. EPA used to have an external peer review and then an internal, kind of fit or priorities. So I think you really have to, not just for NSF, you need to volunteer to be on as many panels for as many different funding agencies as possible. So somewhere along my career, I got ASU had this thing called an exemplar professor. And, after I got this award, I didn't know what I got it for. But, somebody told me, Paul, you got it because you had more different funding sources than anyone's ever had at ASU. And so I really think about a portfolio, not just of the topics, but as many different sources as possible. Makes you a lot more robust. I have friends right now who had EPA ones they're gone, or DOE ones only on certain topics, and they're gone, right? So really diversification of funding sources, but also kind of topics and approaches. So there's a really fun thing. I don't know how many people admit this, but AI, you can have AI review your proposal. If you've done this, you get a lot of interesting insights, especially if you use different AI engines. ChatGPT is just way too nice, for example. So you should not use ChatGPT, right? It's just too kind. So I'll give you some other examples in a moment, but you can create your own template that what you think is important reviewing. Share it with a friend. They can, essentially it's what questions to ask ChatGPT or whoever you play with on these. So this is an interesting, evolution. But I'd say where you really need to be creative is in developing two things: a value proposition. I'm going to talk more about this in a moment, and key insights. But I think it's really having this balance. I call it NABC. I didn't come up with this, but this guy down in the bottom here in the LinkedIn, Kurt Carlson, kind of, modeled this, and we've done a lot with him over the years. So what do I mean by NABC? So we actually wrote a perspective or viewpoint, I guess, in ES&T with Kurt Carlson, who used to be the director of SRI, Stanford Research Institute, where he used this internally to go after everything from DARPA to Siri to math lessons. And Amber Wootich, who's a social scientist, and we had a convergence project together. And she's used this approach to communicate complex ideas with different social scientists. They tested different techniques, and this won in that competition. We used this in our engineering research center, NEWT, that we had with Pedro Alvarez at Rice University, Yale, and University of Texas, El Paso. So I saw Shane on here. So we use this need approach, competition, and benefits to create value propositions. And so if you think, what is a value proposition and what are the elements of good ones? These are an example. This is from our STEPS Center, a Science and Technology Center. And we actually kind of used this during one of our initial pitches to NSF for it. But this is, John F. Kennedy, and you can read it, and I boxed in this decade, right? So it has a metric in it. It's clear. The goal to organize and measure the best of our energies and talents. That's their approach. And what's the benefit? We intend to win, right? And so they start to have some of these elements. This was his value proposition. How many times have you seen or heard, this type of, focus at a political level? But it's good, these types of value propositions. But value propositions are everywhere. You could say, I'm not a politician, but you're trying to convince somebody of something. A reviewer to give you a good score, a funding agency to fund you. And they're everywhere. So you can have quad charts in the, different DoD types of things. And a quad chart has a purpose, customers, desired end result, measures of success. So these are all need, approach, benefit, competition. Startup companies have pitches, right? They have, the same type of thing. And if you take iCore or something, business model, Canvas has these same types of things. Did you listen to customers? What are they telling you? What value are they seeking? What unmet need is out there? And again, so these value propositions and tools to create them are everywhere. And I'll say that, where you want to do, and this looks like it's a business focused thing, but customers or stakeholders are your funding agencies. Whoever has put the money together, they've had to propose and articulate their vision to their higher administration, whether it's the Water Research Foundation and their stakeholders are water and wastewater utilities, or NSF program manager articulating to the Division of Engineering, to the lead of NSF, to Congress, right? If you make a good value proposition at that level, you can fund things. What are your unique capabilities? And what's your competition doing? On this call, we're all competitors, right? And so where you want to place yourself is not in the nexus of all of these. You want to be in this, white space where you're meeting some unmet need that your customers or stakeholders, funding agencies have with your unique capabilities. And so if you really don't differentiate yourself from your competition, then you're going to slide down into that competition. So when you're in that area there, you win and your success rate goes up. All right, so what do I mean by this need, approach, benefit, competition? So you have to have a key insight in the need. So the need, for example, I'll show you an example in a little bit, but a need is not to have clean water. That's not a creative insight. It's not a key insight into a need. I'd say, who should I'll pick, Chris Higgins, did his PhD in 2005, on PFAS. So he had a key insight at the time that these fluorinated surfactants were going to be a problem. right? Okay, the rest of the world didn't know it yet, but later they did. So you need a key need. And that isn't, he didn't pitch necessarily how he did it initially, but there was this interesting class of compounds that are replacing, polyalkyl sulfonates. They're thermally stable. They're used in these different things. And, oh my God, they're stable. Like what happens now? Are they biodegradable, right? So a key need is, that's unmet and unaddressed at the right time of riding a wave. He was looking way out there for that, right? And then your approach also needs a key insight. What is unique about your insight, or what have you proven to be better than, competition? Or what benefit is it bringing? Is it faster? Or can it be done in one day instead of 10 days? Can it be done in 1 hour versus a day? So you should avoid things like better, bigger, faster, slower, right? That doesn't mean anything, and come at this with kind of metrics for these things. And so, how have I thought about riding the wave? This is how I've thought about riding these waves in terms of chemicals in the environment. So, Rachel Carson, I wasn't alive then, right, but wrote Silent Spring about PCBs. So on the right-hand side in the 60s, I'd say that PCBs were emerging contaminants. Over the decade afterwards, the issues became defined, solutions were identified, and then it moves into some regulatory phase. And so you still have PCBs in the environment, but we don't think about PCBs as emerging pollutants. And these are just different things over time, but they all follow the same progression, emerging for some amount of time, and then they become defined. And you can think of this as an S shape or a wave. But, if you're trying to call something an emerging pollutant today, and you say PFAS is an emerging pollutant, I'd say, well, it's probably more in this issues defined and solution space. In fact, maybe even, in the long-term regulatory space. But there's still a lot of research to be done about how to regulate PFAS. I'd say a lot more about is PFAS less than PFAS is a problem. So I think understanding where your stakeholders are along these waves or along these trajectories, and you want to be proposing things that are kind of the next part of this wave. And it's easy for chemicals or pollutants in the environment because I think they all follow this pattern from a higher to lower level of concern. PCBs are still there, they're still a problem, but they're just lower level of concern than they were in the 60s. Does that make sense to people? Maybe? But I think you want to think about where your skill sets are, where you want to be. If you want to write a large center proposal, you have to be at the right part of this wave, maybe. I do a lot of work with, Pedro Alvarez, and he really likes, kind of this pasture quadrant way of thinking about it. It's the same type of thing in terms of where do you want to fall? Where is it on this wave? Use-inspired research is really, have you clearly been able to articulate the need, right? Basic research, like Pasteur kind of stumbled upon things, right? So you can think about where you like to fit, and there's other models. To me, the idea of waves and thinking about need, approach, benefit, competition is a way to think about you. And then most of us fall into one of these boxes. The only one you should avoid is tinkering, right? So that means it has low relevance for immediate applications and low relevance for generalizable knowledge. So avoid tinkering, right? But all these other ones are great places to be. So yeah, as we're kind of going through here, I'll do this, and then kind of if anyone wants to ask about starting companies, maybe we can come back to this slide because there's interesting models. Right now, I'm part of like 6 startup companies, so I've tried each of these different models. Interesting. But right now, translational research is quite well funded, whether it's the TIP program at NSF or Engines programs or They still haven't fully reauthorized SBA, but there's a lot of other incubators and different things that are out there. So I'm going to pause here and let's go back to that the poll. And but any questions while I'm bringing that poll back up, and then I'll spend a few minutes thinking about centers. But any questions?
So, Dr. Westerhoff, since you talked about AI tools
Yeah.
and you are kind of against ChatGPT, which one is your favorite?
Okay, so we can see some of the hot topics. AI is one of them, right? So I'm going to go back here. I don't think I could have asked you to lead in any better into the next slide. So, I'd say that, topics and one thing environmental engineers, then I'll come back and answer your question, is that I realized through all these different administrative things, we don't think big enough, right? We don't think about going to the moon. We think about solving one PFAS in a drinking water system or something. So nothing's wrong with that. But I realized we don't think big enough. A lot of people think a lot bigger. And once I kind of got exposed to this idea of thinking bigger, I've really enjoyed working at these kind of center level types of things. And going back to Garrett's question, rarely did I get more than 1 or 2 students, per year out of these things. And so you put in a lot of time, but you can leverage the heck out of these, right? So whether it's through industry or other things. So I'd say that it's the leveraging that starts to build the value of having these larger efforts. So, going to your question then, Saeed, is there's different models. I really like this guy, Kirk Carlson. If you go to his on LinkedIn, he has this, I4I, or Innovation for Impact. He's worked with different universities. I brought him to ASU 3 times to do workshops with groups of 20 to 25 faculty. So it's a 2-day thing. Everyone always shows up for day 2, tells you something. But if you go to his LinkedIn thing, he has these little templates. And you have to dig through his thing there. But he has these templates. If you want to write a DARPA proposal, it's essentially a value proposition that you can cut and paste and put into ChatGPT as the questions or prompts you should be answering. Then as part of Northwestern, it's more of a proprietary thing in Claude that it's a tool that he's created that allows you to iterate, and you get rankings in about 8 different categories. And so those rankings are, did you answer these types of questions? And so, rarely do you ever get a 10. So like we did something just last semester, and most teams started with like a 3 or 4. And you get up to a 6 or 7, and now you're not quite fundable. That would be like getting goods and very goods, right? And so it really, it's about being iterative and really understanding how to balance these need, approach, benefit competition. So I don't think it's any one AI. I think it's how are you using it and what tools are being developed to enable you to do it. So look him up. He's really good. And if you want to bring him to your university, we're trying to figure out how to clone him. But instead of cloning him, we did this thing within Claude, and it's getting better, but not perfect. So this is just eye candy. I'm not going to go through it, but these are the questions you can be asking yourself when you do these value propositions. So I'll just pick out one. Do you have, a clear beachhead for early adopters? And you say, well, that sounds like a company. Well, okay, imagine you're developing a new instrument. Imagining you're developing a model. Who's going to use this model? Like, why do they need this model, right? So it's really driven by the need. And then you can scan through some of these other ones. And so this is free. It's on his, practice for innovation thing. So Kurt is great. So this is not, I was trying to make this into the last Slido, but STEPS is an NSF Science and Technology Center with NC State as the lead. I'm one of the 2 co-deputy directors. So this was our first version of the mission statement. And it's okay, but it's missing some things. And here on the right is the one that got us funded. So the one on the right has quantifiable metrics, 25 and 25, and we use that kind of throughout our pitch. And the reviewers were writing about it when they recommended funding because and we had a basis for it. We said why 25%. We found support from the UN reports and other things. So we did our homework. We didn't make things up. And we said why a 25% reduction in non-point and point sources would improve the ecosystem, right? So all these have like justifiable things, but a big difference, a subtle difference, but a big difference once you put metrics into these. So I'm almost done. Sorry, I'm going to skip through this last one. So, Garrett asked, going after these bigger proposals, you don't necessarily get more money, but there's ways to make them easier. So I don't know how many people have worked with a proposal manager, but our university provides these to help you write proposals over 5 million. But if you don't know how to work with them, it's hard. So in engineering, we started looking at these for $1 to $5 million range, and people loved them. They were very hesitant initially to work with somebody. But after they did it once, they realized that they offload a lot of the bureaucracy of leading an effort. And that even though it wasn't funded, the team was together. The proposal manager actually helped you look for new opportunities. So they stayed with it. So we have these. Their success rate is about 60% if you work with a good proposal manager. So it almost doubles your success rate. So I usually then encourage people to write them in as project managers. Takes a little bit of money, but it makes the impact of what you're doing better. So up front, they increase success rates. On the back end, they affect your impact that you can make. All right, and then my last opinion, because I've worn different hats. I'm a PI. I've been an administrator. Don't view overhead or F&A facilities as something, a tax or something you should avoid. So if you like having laboratories, if you like having project managers, then you should really kind of realize that this is just part of doing research. It maybe look different in the future, but this is not some pork barrel for all the execs to go off and do things. So those are some of my ideas, some of my opinions. I really think about them strategically. I use data to think about success rate. Where do I spend my time? I still enjoy writing single PI NSF things. I wrote one because it was an opportunity to do something on the International Space Station. I spent about 100 hours on the proposal. It got funded. Just 2 days ago, we had splashdown of our experiments from the International Space Station. So really hard to do, but it was really fun. And it brought like significant value to me. I don't know about the whole community, but it brought real value to me. So you can be selfish or help other people in terms of your value propositions. But with that was my last slide, ending on, facilities and administrative costs. Don't avoid them.
Sure. Thank you, Dr. Westerhoff. So let's open up for questions. If you have any question, please speak. We have around 5-6 minutes. We can stay as long as Dr. Westerhoff.
And we had a few questions in between. Hopefully, kind of broke it up a little bit. But...
Sure.
Garrett, did I answer your question? Is one or two students enough on a large center? I think so.
Yeah, you answered that. I think,
Yeah.
It seems like the point is there's other things of value that come with it, such
sure.
as the infrastructure, the other things beyond
Partners. But again, if you lead one and include other people, you should, the centers I have fun with, like Pedro and I saw Shane walk around here, like we really enjoy working together, right? And so if you take the lead on one thing, likely they will take the lead on something else. It may not always be the same exact group of people, but you learn a lot and people are willing to, take the lead and see that you like being part of centers. And you contribute to them, and then they want you to be part of the ones that they lead. And so the ones they lead isn't as much work as the ones you help lead. So,
Sure. So, Dr. Westerhoff,
Yeah.
since you talked about emerging contaminants and pollutants, and the
Yeah.
last one I saw is microplastics, do you have any insight on the next emerging pollutant? Like
So
which one
the
will be
next, like,
next?
if I did, would I tell you? I don't know. Right. So, if we go back to the bubble cloud, no one else revealed any. Nothing. Everything on there is really things that we're getting funding for today. I could ask the same question about the future. I don't have a crystal ball necessarily. I guess what I try to do, I did not do microplastics. We had done a lot of environmental fate of nanomaterials. While I thought I could provide some value, I actually did my master's on latex particles and filters, which were nanoscale. So I was doing micro and nanoplastics. I just didn't feel like I wanted to stay in that vein, right? So I kind of looked other places. Um, Honestly, my honest answer is things that do things at the quantum level are the next group of emerging contaminants. I don't know what that is, right? So we think a lot about whole organisms, or in environmental engineering. Then we thought a lot about things like at a bacterial level, at a cell level. And so, like PFAS does interesting things as a surfactant at the cellular level. And so I'm just curious, like, there's lots of antidotes of things in the literature. Like, I wanted to have a workshop on quantum biology. I'm not a biologist. I wanted to learn something. Pedro Alvarez and I were going to organize one, but we couldn't find any experts. There's a journal on quantum biology. One guy on the editorial boards here at ASU, he's in physics. So I went over and talked to him. He goes, I don't know what it is, but we started a journal on it. Right. So, there are interesting things that occur at a quantum level. So I think quantum technologies, not just for photonics of computer chips, but quantum biology dictates maybe why birds and salmon migrate. I would look at it in terms of, if you think of magnetic fields, for example, some people think that guides them. Well, okay, it may or may not, but how could it? Right? So we actually got some fish heads, and you can find nanomagnetite that are connected to neurons in birds and fish. All right, is that quantum? Well, most people don't consider magnetic fields quantum, but it's something different than we've considered before. So I would argue that that next thing that we might call a contaminant might come from a very different direction than the way that we've come about. It's a high use chemical, or 6-ppdq, which is a byproduct of a high use chemical. I think people are getting smarter at finding those, but finding these true new classes of things, I think are going to be a little bit different. I don't know. Just an idea. Want to write a paper on quantum biology? You're a biologist.
Thank you. Thank you. Sure. Other questions?
Can I ask one?
Oh, yeah. Go ahead.
Yes. Let's go.
I have a great presentation. So I really like your idea of creating value and being bold. You talk about the center proposals. There are some agencies like DOE, they have the EFRCs, mostly focusing on the basic science. So as environmental engineers, we oftentimes work on maybe more applied research and maybe problem oriented. So how should we think about this more basic science type of center calls?
Yeah. So I'm part of an emerging EFRC, proposal. And so I'd say that, I'm maybe one of the more applied ones, right? But I'd say I'm providing the need for them. So I might not have that unique mechanism that is doing what, we want to do, but I understand like where they're trying to get to in terms of that larger kind of system level piece of it, right? So you can help find and articulate the need to drive the fundamental science part of it. So that's one way to think about, basic science. The other is I really would push back and say, there must be some basic science going on in your lab. Maybe you don't think it's basic enough, but maybe you can't lead an EFRC on it, but it's probably in there, right? Or if you want to lead an EFRC down the road, you should be doing something. So there's another book that I like. It's called The One Thing by this guy, Gary Keller. So I didn't stumble upon it. People told me about it. And so what you do is, let's say you want to write an EFRC in 4 years from now, right? If you set that as a goal, I'd argue, what do you need to do in 2 years from now such that you can lead a proposal to an EFRC in 4 years? And then you might come up with an answer. And I'd say, well, what do you need to do in 1 year in order in 2 years you can be in that position? Then 6 months, then 3 months, then 1 month, then a week, then tomorrow, right? So if you really have one goal, and I'll tell you that this works. This really does work. You can set big, I've set big ambitious goals, but you can't have 10. You really need one. And there's other in that book that talk about time blocking and how do you really create this room when you're busy to do things. There's a lot of busy people in the world who accomplish really bold things. And it's because they can focus and really break down a goal coming back to what should they be doing, tomorrow. Yeah.
This
So
is
you
very
can do
helpful.
it.
Thank you.
Hopefully you don't beat us though.
Thank you so much.
Please
there.
go ahead.
Hi, this is Jinghua from Clemson University. I have a quick question. You mentioned about you are involved in 6 startup. How you manage a list and work with them?
Yeah. So again, I appreciate everyone coming. I know we went over, but I'm going to show a slide. That's one of my favorite slides. It's not my slide. So I want to give this guy, full credit here. His name is Zach Holman here at ASU. He came up with this fun slide, I think, that kind of articulates things pretty well. So, he envisions maybe there's a fifth way of how faculty, engineering faculty should be or could be part of a startup. So the bottom is the startup. So on the left, you kind of leave your position or you try to do both and you are the CEO. This largely doesn't work, I think. I've not seen too many examples because faculty have too short of an attention span. And that, again, we all know people who've done this, probably not the one I would encourage. The one on the far right is you submit a patent and you hope somebody comes along and licenses it. Well, that's okay. It's kind of high risk that you're just waiting. We did one of these recently. We actually submitted a patent that we never did much research on about 8 years ago. But a company came along and they were looking through portfolios of water technologies and they found one. And then they are licensed it and I'm helping them in it. So that's one of these startup companies. The ones in the middle then is you train a lead entrepreneur. So maybe a postdoc or someone. And the faculty members kind of part-time in it. Maybe I'd say faculty are pretty good as being a CTO or a science advisor rather than leading things. And then the others, you hire an entrepreneur. So one of our companies, we did a NASA phase 1, phase 2, phase 2E, phase 3, and we have a contract with NASA, and now we're just bringing on a CEO. And we kind of knew this person, but they said, actually, you're at a stage now where I can finally help you, right? So you have to know when to say no or to get out of these. So I've tried all these. They're all interesting. Yeah, I don't know the answer yet because I have not made my $1 billion, as an exit, but they are fun and they really get you to force to think about creating value. Yeah, I don't know. Have you tried one of these?
Me? Not yet.
Yeah.
I'm curious how this gonna work.
Yeah, the ones in the orange box are the ones Zach Holman thinks are the best route for engineering faculty. So Zach was a young whippersnapper faculty member in electrical engineering when I was a vice dean. I put him on a committee and I talked to him and I said, Zach, what do you want to do when you grow up? He goes, I want your job. So now he's the vice dean of engineering at ASU. So really bright guy who very thoughtful, as you can see here, about how engineering faculty can have impact. And he's part of 4 startup companies.
Wow. Okay. good to know. Thank you for sharing.
All right. Well, good, Saeed. I'm again happy to stay on, but thanks for inviting me. Hopefully somebody got something out of it they weren't expecting. So.
Sure. Thank you for your time, Dr. Westerhoff. Any other questions? Dr. Westerhoff, I think I can ask the final question.
Okay.
So when you were like younger in the academic hierarchy, like did you often respond to noises? Like did you try proposals outside of your expertise, and how often did you do it? Like what triggered those responses?
Yeah, so I have no fear. I'll submit a proposal, anywhere. I'll do creative things. So I wrote one that I was kind of having fun with. So the first page of the proposal is actually, like a theatrical dialogue between two people. It was between a water buffalo. So in Arizona, water buffaloes are people who, hoard water resources and stuff, and a Canadian Monty, the rangers of sorts in the Canadian, policing. And so it was this dialogue, and they were talking about, water, and the water buffalo said, "Can you send us hydrogen? You have a lot of water up there. You have all these electric, dams. You can hydrolyze hydrogen and send it to us." And here in Arizona, and they went back and forth. And the proposal was about, this was in 2005 or so, if we had hydrogen fuel cells, could we make clean drinking water? And they went back and forth, and the Canadian Monty finally said no, because he said the water buffalo was trying to steal his water. But if you move hydrogen, you have oxygen everywhere. So at that point, I had never written a proposal on hydrogen. I knew nothing about fuel cells, but I listened to people, and even then, people were talking about a hydrogen economy. So I was interested in what could be the consequence, the beneficial consequence of a hydrogen society. And I had talked to our power provider, and they had hydrogen fueling stations, and they complained about water leaking out of their fuel cells. And so we talked about it, and they wanted an answer of how much water would it be, and would it make a meaningful difference. So it got funded by the Water Research Foundation.
Wow.
So yeah, feel free to, they had never funded a project before that on hydrogen. So sometimes it's not just a risk for you, it's a risk for the funder as well.
For sure.
Yeah,
Thank you.
but definitely step out of your box and do things.
Sure. Thank you.
All right. Great.
Any other last question? Thank you, Dr. Westerhoff. We really appreciate your time, and I'll share the recording with you later on.
Okay.
Thank you.
Thank
you, everyone. Thank you. Enjoy the day.
Good questions. Bye-bye.
Thank you.
Bye.